Hey everyone, welcome to EduTube channel. In this video, we're solving questions from the CIE Additional Mathematics, October 2023 Paper 1, Version 1. In question 1, the diagram shows a graph of a cosine function. We are asked to find the values of a, b, and c. Looking at the graph, we notice that the maximum value on the y-axis is -1, and the minimum value is -9. This gives us a vertical distance from peak to trough of 8 units. So the amplitude, or the value of a, is half of this range, which is 4. Next, we find the value of c, the vertical translation. The center line of the wave lies halfway between the maximum and minimum. Then, c is -5. Now let's determine the value of b. Looking at the graph, a full wave starts at -540 degrees and ends at 540 degrees. So the period is 1080 degrees. In a standard cosine function, the period is 360 degrees. 1080 divided by b is 360. Solving this, b is 3. So finally, we have a equals 4, b equals 3, c is -5. In question 2, p of x is a cubic polynomial. P of x is divisible by x and has a remainder of 2/3 when divided by 2x plus 1. The derivative of p at x equals 2 is 18. If a polynomial is divisible by x, then plugging in x equals 0 must give 0. So we substitute 0 into the polynomial, and the result is just c, so c must equal 0. When a polynomial is divided by 2x plus 1, p of -½ equals the remainder, 3/2. Substitute -1/2 into the polynomial, and simplifying the equation, we get a plus 4b equals -34. The derivative of the polynomial is 3ax squared minus 22x plus b. The value of this derivative when x equals 2 is 18. Substitute 2 into the expression, and simplifying the expression, we get 12a plus b equals 62. We now solve these two equations. Start by multiplying the second equation by 4, so we can eliminate b. That gives 48a plus 4b equals 248. Subtract the first equation from this one. 4b cancel out, and we get 47a equals 282. So a equals 6. Substitute a equals 6 into the second equation, then b equals -10. Now we have the full polynomial. 6x cubed minus 11x squared minus 10x. We can factor out x to get x times 6x squared minus 11x minus 10. Now factor the quadratic into 3x plus 2 times 2x minus 5. P of x as a product of linear factors is x times 3x plus 2 times 2x minus 5. In question 3, point A has a position vector with coordinates 2 and -6, and point B has a position vector with coordinates -3 and 6. To find vector from A to B, we subtract the coordinates of A from the coordinates of B. Vector AB is -5 and 12. To calculate the distance between 2 points, we use the Pythagorean theorem. The horizontal change is 5 units, and the vertical change is 12 units. Square root of 5 squared and 12 squared is 13. So the distance AB is 13 units. In part C, 3 times vector AB is equal to 2 times vector AX. This means vector AX is 3/2 of vector AB. Since vector AB is -5 and 12, vector AX is -7.5 and 18. From O to X, we can go from O to A, and then from A to X. Vector OA is 2 and -6, and vector AX is -7.5 and 18. Adding the values from vector OA and vector AX. Position vector of point X is -5.5 and 12. This completes question 3. In question 4, a table shows values of x and corresponding values of y. The relationship between x and y is expressed by the equation y equals a times x raised to the power of b. To turn this into a linear relationship, we apply natural logarithm to both sides of the equation. Using logarithmic rules, natural log of y equals b times the natural log of x plus natural log of a. This expression is comparable to straight-line equation, y equals mx plus c. The vertical axis is the natural log of y, and the horizontal axis is the natural log of x. Coordinate points are as follows. When x is 1, natural log of x is 0, and the natural log of y is approximately 3. When x is 2, natural log of x is approximately 0.69, and natural log of y is about 4.04. When x is 3, natural log of x is about 1.1, and natural log of y is roughly 4.64. When x is 4, natural log of x is approximately 1.39, and natural log of y is about 5.08. When x is 5, natural log of x is 1.61, and natural log of y is about 5.41. Plotting these points on a graph gives a straight line. This line can then be used to estimate the constants a and b. The slope of the line is b, and the vertical intercept is natural log of a. This means natural log of a is 3. Solving this gives a as 20. To find the value of b, which is the slope of the line, we take 2 points from the graph, 0, 3, and 1.61, 5.41. So b is estimated to be 1.5, rounded to 2 significant figures. In part C, to estimate the value of y when x is 3.5, we first find the natural log of 3.5, which is approximately 1.25. The corresponding value of natural log of y is around 4.9. To find y, we take the exponential of 4.9, which gives approximately 134. So, when x is 3.5, y is around 134. This completes question 4. In question 5, there are 10 digits from 0 to 9. In a 4-digit code, digit must not be repeated, but the code is allowed to start with 0. To form the code, we are selecting and arranging 4 digits from the 10 available. This is a permutation of 10 items taken 4 at a time. The calculation gives 5,040 possible codes. Next, the last digit must be odd. There are 5 odd digits, 1, 3, 5, 7, and 9. That means there are 5 odd digits to choose from for the last position. Once the last digit is chosen, we have 9 digits left to fill the first 3 positions, and we are choosing and arranging 3 of them. So, we compute the number of arrangements, which gives us 2,520 codes that end with an odd number. Next, to form a number greater than 1,000, the first digit must not be 0. So we are limited to 9 digits, from 1 through 9. After choosing the first digit, we still have 9 digits, and we are choosing and arranging 3 of them. So the total number of such codes is 4,536. A different scenario is given in Part B, choosing a team of 9 people from a total group of 15. There is a family of 4 among these 15 people, and this family must either be included together or not at all. We need to find how many valid 9-person teams can be formed under this restriction. If the family of 4 is included in the team, we need to choose 5 additional people from the remaining 11 individuals. This gives 462 teams in this case. If the family is not included in the team, then we must choose all 9 members from the remaining 11 people. This gives us 55 teams in this case. Adding the 2 cases together, the teams that include the family or exclude the family gives a total of 517 teams. This completes question 5. In question 6, the given expression is written into a single base 10 logarithm. First, we apply the power rule, so the first term becomes the logarithm of x cubed, and the second term becomes the logarithm of the square root of 4, which is equivalent to the logarithm of 2. 2 can be expressed as the logarithm of 100. Using the rules for combining logarithms, Subtract the logarithm of 2 means divide by 2, and add the logarithm of 100 means multiply by 100. The result is the logarithm of 50 times x cubed. In part B, we are solving an equation involving logarithms. We start by letting the logarithm base a of 4 be equal to y. Then the logarithm base 4 of a is 1 over y. Substituting into the equation, 2y minus 3 over y minus 5 equals 0. Multiply by y to eliminate the fraction, and we get the quadratic equation 2y squared minus 5y minus 3 equals 0. Solving this, we get two possible values for y, -1/2 and 3. Since y represents the logarithm base a of 4, we can solve for a by rewriting the equation in exponential form. If y is -1/2, then a is 1 over 16. If y is 3, then a is the cube root of 4. Therefore, the two exact solutions for a are 1 over 16 and the cube root of 4. In part A, we are given a function defined as the product of two expressions. The first expression is 2x plus 1, and the second expression is 3x minus 2 squared. We need to write the derivative of this function in the given form. We apply the product rule. First, we differentiate the expression 2x plus 1, which gives 2, then multiply by 3x minus 2 squared. Next, we differentiate 3x minus 2 squared, which is 2 times 3 times 3x minus 2, then multiply this by 2x plus 1. Putting both parts together, and then factor out the common term 3x minus 2 from both parts of the expression. This gives us 2 times 3x minus 2 multiplied by 9x plus 1. In part B, we need to find the stationary points of the function, where the derivative is equal to 0. Setting the derivative from part A equal to 0, we get two values for x. If 3x minus 2 equals 0, then x is equal to 2/3. If 9x plus 1 equals 0, then x is equal to -1/9. We substitute them back into the original function to find the corresponding y coordinates. When x is 2/3, y is 0. When x is -1/9, y is approximately 4.23. Therefore, the two stationary points are at the coordinates 2/3, 0, and -1/9, 4.23. Now we need to sketch the graph of the original function, labeling the intercepts and stationary points. The x-intercepts are -1/2 and 3 over 2, and y-intercept is 4, which is obtained by substituting x equals 0. The stationary points, as calculated earlier, are at 2/3, 0, and -1/9, 4.23. Using this information, we can sketch the curve. The curve passes through the x-axis at the intercepts and reaches a maximum or minimum at the stationary points, forming a smooth, continuous graph. Finally, f of x equals k has three distinct solutions. For three distinct solutions, the horizontal line must cut through the graph at exactly 3 different points. By looking at the graph, we can see that this only happens for horizontal lines that lie between y equals 0 and y equals 4.23. Therefore, the value of k must be greater than 0 and less than 4.23. This completes question 7. In question 8, the diagram shows a straight line whose equation is y equals 1 minus 4x and a curve whose equation is y equals 4x squared minus 6x minus 5. These two graphs intersect at 2 points, labeled A and B. The straight line passes horizontally through point A and tangent line to the curve at point B meet at point C. We need to find the x-coordinate of point C. First, we find the coordinates of intersection points A and B by setting the two equations equal. 4x squared minus 6x minus 5 is equal to 1 minus 4x. By rearranging the equation and simplifying, we get a quadratic equation. 2x squared minus x minus 3 equals 0. Solving this equation gives two values for x, which are -1 and 1.5. Substituting each of these x values into straight line equation gives the corresponding y values. When x is -1, y is 5. When x is 1.5, y value is -5. Point A is at coordinates -1 and 5, and point B is at coordinates 1.5 and -5. Thus, the equation for the horizontal line through A is y equals 5. Next, we calculate the gradient of the curve at point B by differentiating the curve's equation. The derivative of the curve is 8x minus 6. Substituting x equals 1.5 gives a gradient of 6. The tangent line passes through points B and C and has a gradient of 6. Using the slope formula, we substitute the coordinate values of B and C. Solving the equation gives a final answer of 3.17, correct to 2 decimal places. So, the x-coordinate of point C is approximately 3.17. In question 9, the first 3 terms of an arithmetic progression are -3 tangent of theta over 2, negative tangent of theta over 2, and tangent of theta over 2. To make this simpler, let's say that x is equal to tangent of theta over 2. Then, the 3 terms become negative 3x, negative x, and x. Then first term is negative 3x, and the common difference is 2x. The 12th term is a plus 11d. A is negative 3x and d is 2x, which simplifies to 19x. The 12th term of this sequence is equal to 19 root of 3 divided by 3. Dividing both sides by 19, x equals square root of 3 divided by 3. Remember, we had said x equals tangent of theta over 2. This is a known trigonometric value, tangent of 30 degrees, or pi over 6 in radians. Therefore, theta is 60 degrees, or pi over 3. Then we need to find the exact value of the sum of the first 10 terms of this progression. Using the formula, S10 equals 10 over 2 a plus 9d. Substituting the corresponding values and simplifying gives 60x. Now we substitute x equals square root of 3 divided by 3. The exact value of the sum of the first 10 terms is 20 square root of 3. In part B, the first 3 terms of the progression are given. We need to find the possible values of phi. The sum of the third and fourth terms is equal to 4. Since the third term is 1, the fourth term is 3. In geometric progression, the ratio of successive terms is equal. So, the ratio of third term and second term is equal to the ratio of fourth term and third term. The left side of the equation is equivalent to 4 sine squared. To solve this, divide both sides of the equation by 4 and take square root. Since phi is between negative pi over 2 and pi over 2 radians, 2 possible angles of phi are positive pi over 3 and negative pi over 3. Next, we need to determine whether the progression has a sum to infinity. We check the value of the common ratio, which equals 3. Since the common ratio is greater than 1, this geometric progression does not have a sum to infinity. A geometric progression only has a sum to infinity when the absolute value of the common ratio is less than 1. This completes question 9. In question 10, y equals the square root of 3x squared minus 2 divided by x minus 4. We need to express the derivative of y with respect to x in a specific form. We need to apply the quotient rule to differentiate a fraction. The denominator is x minus 4 squared. The numerator is x minus 4 times the derivative of the square root expression, which is half times 6x times 3x squared minus 2 raised to the power of negative half. Then we subtract 3x squared minus 2 raised to the power of half times the derivative of the denominator, which is 1. To write in the given form, we multiply both numerator and denominator by 3x squared minus 2 raised to the power of half. After simplifying everything, we factor and combine terms. The final expression for dy by dx becomes negative 12x plus 2 divided by x minus 4 squared times the square root of 3x squared minus 2. That matches the required form, where a is negative 12 and b is 2. Now let's move to part B to estimate the change in y when x increases from 3 to 3 plus h. Since the change is small, we can use the formula delta y is approximately equal to dy by dx times delta x. We can use dy over dx from part A, and delta x is h. We substitute x equals 3. Simplifying the expression gives negative 34 over 5 times h. Thus, the approximate change in y is negative 6.8 h. This completes question 10.